So find pivot index. So we have given an array of integer nums, and then we have to calculate the pivot index of this array. So the pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the right of it. So if the index on the left edge of the array is the sum is 0, because there is no element to the left, so this applies to the right edge of the array as well. Okay, so return the leftmost pivot index. If no such index exists, return -1. Okay, so let's understand this with the example. So we have given nums and 1, 7, 3, 6, 5 and 6 again. So these are the values in the index, in the num, sorry. So now what we have to do is, they are saying that if let's say our pointer is on the first index where index is equals to 0, then we have to set like left of it is equals to 0, and the right of it is if we are looking for the last index, then also the right of it we have to take the sum as 0. Okay, so now what we have to do is, basically we have to take this particular pointer and move it in the array towards the right side, and we need to find out at which position the left side of the array sum is equals to the right side of the array sum. So for example, here 1, 7, 3, 6, 5, 6. Okay, so initially we had it at 1, so let's take left and right. So these are denoting the sum on the left side and the sum on the right side. Okay, so at if we take the initial position, let's put index in here. So index, let's say for index I equals to 0, so what we get is, on the left side, if we don't have any element, we start with 0. Okay, and then on the right side, so we have to exclude this particular term, and the other elements on the right side are here and on the left side are here. Okay, so considering that, so it would be 7 plus 3 plus 6 plus 5 plus 6. Okay, and that would be equals to 10, 12, 22 and 5, 27. Okay, so now what we have to do is, we have to move the pointer to the next, because 27 is not equals to the sum, like the sum on the right is not equals to the same sum on the left. So we move to the next index, and then we see if we are at here, then the left side includes 0 and 1, so let's say the sum is 1, and similarly we have the right side as 3 plus 6 plus 5 plus 6. Okay, so similarly we'll do the addition and all. So after this we have okay, let's do this addition. 639 and 5 6 5 11 11 plus 9 is 20. Okay, so we got 20 as the sum, so 20 is not equals to the 1. Okay, so move to the next index equals to 2, so the value is 3 here, index value, but we have to calculate the left and the right. So the left is 1 plus 7 and the right is 6 plus 5 plus 6, so that is equals to 12 plus 5, so 17, and this is 8, still not there. So move to the next index, so here we are, and then 1 plus 7 plus 3, and then here 5 plus 6, so 17, 11, and this is also 11. So here we can see at index 3 we are getting left side and the right side both as 11. So this is the required index that we need to return. So let's say we move to the end of the array and we didn't find any particular index or the pivot point where we could see the index on the so the left sum is equals to the right sum. So then we have to return -1. So let's code this. So here I have taken two sums. So basically what I have done is uh, we have iterated through the array once and we have calculated the sum. So we will get the value of all the elements like 1 plus 7 plus 3 plus 6 plus 5 plus 6. So that will return 28. So that would be the sum that we will get. And then what we are doing, we are iterating again, and this time we already know the sum. So what we are doing is from sum 2 we are subtracting that. So sum 2 is nothing but the current iteration sum that we are calculating. Okay, so subtracting that, and we are subtracting the current index value as well, because we don't want to include that when we are calculating the right or the left side. Okay, so this value will represent the right side of the sum of all the elements. So this is equal to sum of all the right elements on I equals to 0, and then this is the left side. So initially we have included the value as 0, so that would return 0 is not equals to the 27, that condition initially. So if this condition is not successful, then what we are doing, we are just adding nums I to the sum 2. So basically what we are doing, we are iterating through it and calculating the sum of at every particular index. Okay, so that's how we are calculating the value of sum on the left and the right side. So if this condition is successful anywhere, then we will return the value of that particular index. If we are not getting that index, then we are returning -1. So that's how we could do this. And so the time complexity of this is like O of n plus O of n. So we are iterating the array 2 times, but we are actually like doing it separately. So O of n plus O n of n. So that will return O of n. So after that, so we are not storing much. We are storing only the constants. So the storage is O of 1. So yeah, that's all.